The appearance of interstellar objects in the solar system is no longer considered extraordinary, yet every new visitor raises new questions. Just a few years after the first discoveries, it became clear that interstellar space is filled with numerous fragments that have left their home systems. The arrival of 3I Atlas became another link in this chain, but the reaction of the scientific community turned out to be far more intense than expected. This was due not only to the unusual properties of the object itself, but also to the wave of information noise created at the intersection of scientific speculation and public fascination. Against this background, NASA's attempts to explain the events within a strict scientific framework only fueled interest in 3I Atlas, which proved significantly more resistant to destruction than comets previously observed and demonstrated spectral characteristics atypical for bodies of the solar system. Initially, it seemed that interest in the object would grow gradually, as usually happens with small, inconspicuous discoveries. However, early reports of supposed fragmentation incorrectly attributed to 3 Atlas immediately took the discussion to a new level. Observations soon made it clear that the disintegrating body was not the interstellar comet at all, but a completely different object. C-2125KY1 Atlas, which had a similar designation, but no relation to 3I Atlas. Images from mid-November 2025 clearly showed at least 3 large fragments of that comet's nucleus, and at higher resolution, an entire swarm of smaller debris could be seen. It was already apparent that the year would be record-breaking for comet disintegration. Earlier in November, the bright comet C-2025-R2 Swan broke apart, followed shortly afterward by the collapse of the nucleus of comet Gennady-Borisov C-2025-V1. This string of events only emphasized the remarkable stability of 3I Atlas. Meanwhile, 3I Atlas was crossing an important threshold 300 million kilometers from Earth. Its approach was driven primarily by Earth's own motion, as the planet's orbital path during this period pointed almost directly toward the region of the sky where the object was located. At the same time, the object itself was moving tangentially and, relative to the Sun, was already on its way out of the solar system, even as it continued to draw slightly closer to Earth. Earth and 3I Atlas would remain on converging trajectories for nearly 4 weeks, until December 19th, when the distance between them would reach a minimum of about 269 million kilometers. After that, the trajectories would begin to diverge. Throughout the previous month, estimates of the closest approach had been revised several times due to substantial non-gravitational acceleration. Nevertheless, calculations indicated that the object would not cross the next significant threshold of 200 million kilometers under any realistic scenario. If it did, the narrator jokes, it would be time to start digging a bunker. The object is genuinely fascinating, and the reasons for that deserve explanation. The accumulated data now confirms that 3I Atlas not only survived its close passage by the Sun, but also endured several direct impacts from solar plasma. Repeatedly exposed to dense waves of charged particles, it showed no signs of structural damage. This resilience was especially striking in contrast to the recent disintegration of several sun-grazing comets with much more fragile nuclei. As a result, discussions arose about the possibility of a dense metallic core. The scientific community, however, attempted to keep the debate within the bounds of physical models without invoking exotic, alien technology. Meanwhile, solar activity remained high. After nearly a month of relative quiet, a new plasma cloud from the November 17th solar ejection was moving toward the object. Calculations showed that it would reach 3I Atlas by the end of the month, making upcoming observations particularly important, especially in radio frequencies, which can reveal changes in temperature and details of the object's interaction with the solar environment. In anticipation of this, NASA held a conference and finally released a long-awaited image of 3I Atlas obtained by the HiRISE camera on the Mars Reconnaissance Orbiter, MRO. Although the photograph was taken back on October 2, 2025, it was not published until 6 weeks later. Despite the capabilities of HiRISE, the image revealed no new structural features of the core. It only confirmed its previously observed shape and lack of fragmentation. Many researchers expressed confusion, noting that the spacecraft had been relatively close to the object, yet no anomalies were detected. Along with the image, NASA presented Hubble and James Webb data that had already been circulating among researchers. Spectroscopy confirmed unusual chemical ratios, extremely rare for bodies formed within the solar system, further strengthening the object's interstellar classification. Non-gravitational acceleration was also confirmed. In itself, this is not unusual for comets. However, the combination of spectral anomalies and unusual dynamics once again set 3I Atlas apart from typical cometary bodies. NASA emphasized that such features were fully consistent with the hypothesis that an interstellar body could possess a composition fundamentally different from solar system objects. Despite the scientific tone, the conference felt more like an attempt to contain growing public interest than a confident presentation of results. No clear answer was given about whether additional images or data would be released. Meanwhile, the central scientific task remained understanding the nature of the object's radio emissions. Radio observations of comets have always been difficult. They emit weakly, and most signals are drowned out by noise. But for interstellar objects, radio frequencies can reveal unique features not characteristic of solar system comets, including chemical line differences and unusual responses to the solar wind. In certain conditions, it is even possible to detect signatures of internal processes. Unlike the sun-grazing comets that disintegrated during the same time period, 3I Atlas showed extraordinary stability, which directly influenced its radio profile. When a comet's nucleus breaks apart, its radio source becomes complex, dominated by dust and gas emissions. A stable, intact interstellar object produces the opposite pattern. Weak but steady thermal emission from a cool, solid surface with significantly weaker gas lines. This is exactly what observations of 3I Atlas revealed. Weak but stable radio emission dominated by CO2. This supported the model of a dense, highly stable nucleus in which volatiles are unevenly distributed and possibly insulated beneath surface layers. NASA has remained cautious. No data indicates an artificial or technological origin for 3I Atlas. However, an informal hypothesis persists within the scientific community, suggesting that the object might contain a high proportion of metallic material or even a metallic structure unusual for comets. Such ideas are not shared publicly, but they continue to circulate among researchers. To assess this possibility, several types of measurements are needed. Polarization studies of reflected light can indicate whether the surface is smooth or unusually dense. For 3I Atlas, such data remains too sparse to be conclusive. Any deviation from a standard cometary phase curve could suggest an unusually rigid structure. Thermal behavior is another clue. Metallic bodies heat up and cool down slowly. NASA emphasizes that without repeated measurements at different phase angles, such conclusions remain speculative. Radar observations would be more definitive, as radar reflects strongly from metallic surfaces. However, the object's extreme distance makes radar studies impossible at present. The dynamics of its motion also draw attention. While its non-gravitational acceleration is confirmed, NASA notes the complete absence of signs of controlled thrust or intentional trajectory changes. Another indicator of artificial origin would be narrowband radio signals. None have been detected. Although the metallic core hypothesis is intriguing, each argument in favor of it has plausible natural explanations. Only independent, consistent data from infrared polarimetry, X-ray spectroscopy, and radar could elevate the idea beyond speculation. Some NASA specialists are reportedly discussing the possibility informally, but the overall scientific stance highlights the diversity of interstellar objects rather than pointing toward artificiality. It is crucial to understand that no single characteristic, high reflectivity, unusual thermal behavior, strong radar response, indicates a metallic artifact on its own. These could also be explained by ice crusts, dense rocky cores, or highly conductive minerals buried under surface layers. However, if multiple independent indicators aligned simultaneously, metallic luster, unusual thermal inertia, strong radar return, anomalous polarization, then the hypothesis would gain significant weight. In simple terms, a metallic object in space would sing in radio and thermal frequencies with a distinct voice. As for what would happen if we discovered something more than a natural fragment of metal, I can hardly imagine it. Thanks for watching until the end. Don't forget to subscribe. Links are in the description. In the meantime, we'll continue observing.